Well, thanks.
So this week's theme, we're following up on our rockets theme that we did a couple weeks ago. Had lots of amazing questions about rockets then, and now we're going to talk about really the future. When we're talking about the future, how far into the future are we talking about here, Rachel?
Well, I start with a little bit of the past, a little history, and then present day, and then the near future, and then we end with the distant future.
Okay, this sounds really fun. So for everyone out there on YouTube land, please put your comments into the comment chat. For everyone out there on Telesoptic, hello. You won't be able to interact with us, but hopefully if you'd like to interact with us in the future, we've got lots of amazing themes coming up. You just join in on YouTube and you can ask Rachel questions in person. So after we do a little presentation, then we can open up the floor to any questions. There are lots of stuff that is happening up there in the sky, and maybe we'll talk about some of those fun things as well. But for now, Rachel, let's get into the future of rockets.
For sure. So I'm just going to quickly share my screen here. And here we go. So you should be able to see the future of rockets in just a few minutes here. So I thought the best thing to do would be to start with the definition of a rocket. So a rocket is a vehicle, often cylindrical in shape, that uses liquid or solid propellants to provide thrust and accelerate the vehicle through Newton's third law. Robert Goddard was the father of modern rocketry, and he built and successfully launched the world's first liquid-fueled rocket back in 1926. It was the forerunner for the Saturn V rocket, 43 years later, that brought humanity to the moon for the first time. Now, most recently, the reusable Falcon 9 rocket is bringing cargo and crew to the International Space Station. So how does a rocket work? Well, in the vacuum of space, an engine has nothing to push against. So how do they work in space? It actually all comes down to Newton's third law. So you're probably aware that the Earth pulls down on you, and that's the force of gravity due to the Earth, and that same force that gives you your weight. What you might not realize is that you're actually also pulling up on the Earth. So if you take a typical Canadian male, let's say Michael, who weighs around 80 kilograms, then the Earth is pulling down on Michael with a gravitational force of around 700 to 800 newtons. But that also means that Michael is pulling up on the Earth with also a force of 7 to 800 newtons, and that's because of Newton's third law. Now, Newton's third law says that if an object, A, in this case, we're going to say that's the Earth, exerts a force on object B, we're going to say that's Michael, then object B must exert a force of equal strength and opposite direction back on object A. And the same thing happens with rockets. The rocket pushes on the hot gas, we call that the action force, and the hot gas being expelled actually pushes on the rocket, and we call that the reaction force. And this law represents a symmetry in nature, that forces always occur in pairs, and it allows rockets to exist. Now, there are two main types of rocket engines. Some rockets use liquid fuel, like the main engines on the Space Shuttle Orbiter or on Russian Soyuz rockets, and others use solid fuels, like on the side of the Space Shuttle. Fireworks and model rockets also fly using solid fuels. Now, the Saturn V rocket used liquid oxygen to provide the thrust needed to carry it into space. Now, the question is, how much did it use? Well, here's a fun little clip showing you the fuel consumption of the Saturn V rocket in terms of elephants. So this is how much fuel the Saturn V rocket took in units of elephants to blast off into space. And I always think that's a really fun way to show that. Now, besides Newton's third law, there's one essential piece of math that keeps rockets in the air, and that is the Tsiolkovsky rocket equation. Now, this equation captures the essentials of rocket flight physics, or what we call astrodynamics, in a single, short mathematical expression. Now, this equation is really important for many aspects of rocketry, like fuel efficiency, because the more amount of propellant you have, it increases your total weight, and thus also increases your fuel consumption. And we can also apply this equation to orbital maneuvers to figure out how much propellant we need to change into a new orbit. And I always like to show this equation because with this little piece of math, we were able to send humans to the moon, and I think that's very powerful. But let's say we want to go to Mars, somewhere a little bit further. By using current technology in a spacecraft powered by chemical rocket engines like NASA and SpaceX, a trip to Mars could take anywhere between 6 to 9 months. This is proven technology, but it's slow. So because of the alignment of Mars and Earth, our best chance to launch occurs every 26 months. So we need to find other ways to travel to Mars and beyond, and we're currently considering alternate propulsion systems. NASA is exploring nuclear power as an alternative means for space travel. After leaving NASA, astronaut Chang Dia set up the Ad Astra Rocket Company, which is dedicated to the development of advanced plasma rocket propulsion technology. And years of research and development have produced something called Vasimir, which is an electric thruster for use in space. And the hope is that this new technology can shorten the trip to Mars from 6 to 9 months to 39 days. So how does it work? Well, let's think back to the rocket engine. A rocket engine is a canister holding high pressure gas. When you open a hole at one end, the gas bursts out of the rocket and the rocket goes the other way. Now, the hotter the stuff in the canister, the faster the gas leaves it and the faster the rocket goes. But if it's too hot, then it could melt the canister. Now, for this type of engine, when a gas gets above 10,000 degrees Kelvin, it actually changes into plasma, and that's an electrically charged soup of particles. Now, these particles can be held together by a magnetic field. So the magnetic field is kind of like a canister that you see in a rocket engine. And there's no limit to how hot you can make the plasma, so we're not worried about melting anything. Now, this type of engine could also protect astronauts from the dangerous effects of radiation during their trip because the trip would be a lot shorter, you'd lessen exposure time. It'd also be more fuel efficient because it runs on hydrogen, and hydrogen can be really found anywhere in our solar system. But there are still a few wrinkles that need to be ironed out with this idea. So let's look at something more familiar and talk about the reusable rockets of SpaceX. On the left here, we have the Falcon 9 rocket that took Crew Dragon spacecraft to the ISS. It was the first crewed orbital spaceflight launched from the US since the final space shuttle mission back in 2011. And it's also the first ever to be operated by a commercial provider. But what's really cool is that they were able to land the first stage of the rocket on a barge in the ocean to be reused later. The Falcon 1, 9, and Heavy rockets all are equipped with something called a MacMillan engine, which uses liquid oxygen and refined kerosene as propellants. Now, the MacMillan engine was originally discovered or designed for sea recovery and reuse, making it the perfect engine for reusable rockets. Now, SpaceX has 2 of these barges, and I thought it'd be a fun note to end on. The names of these 2. Now, you might have heard them. The first one is called Just Read the Instructions, and the recent mission landed. Now, as of June this year, there have been 43 Falcon 9 flights that have attempted to land on a drone ship, with just 34 of them succeeding. So that's just under 80%, so not quite an A for Elon Musk. So what's the next in the story of humanity's journey to the cosmos? Could it be faster than light travel, wormholes, warp drives? Who knows? But I'm excited to see what we come up with now and in the future.
Awesome. Thanks, Rachel. So, of course, like all the questions that you have for Rachel about the future of rockets, let's put them into the chat. And then, of course, we can talk about so much. There's a lot going up there in space. But, you know, when thinking about the future of rockets, of course, Mars is the particular destination that we are thinking about. Now, what about future missions? Because like a lot of the missions that are being planned, you know, out to Jupiter, and even like ones where we talk about going out to say Neptune or Uranus or any of these, is there any ideas out there beyond sort of like what you just talked about?
Yeah, so I think with going further to the outer gas giants, it is kind of still in the drawing board stages, and that's because we really want to have a proof of concept, having the lunar gateway around the moon, and then eventually getting to Mars. And having that first trip to Mars is really essential for us to prove that we can perfect this kind of transportation to further planets.
Right. And what would be sort of like if you were to like design, like for you, like do you have an opinion? Because I think a lot of times when I think about, you know, the future of rockets and lots of different scientists coming up with different ideas, you know, there are differing opinions, and it does sort of like get down to perhaps preferences. And I always think about, you know, perhaps some politics come into play because private companies, you know, develop certain types of rockets, and perhaps those companies, you know, maybe have a more of an in, you know, it does become sort of maybe a little bit of a political conversation. But just on a pure, you know, physics science standpoint, like, do you have a preference?
Between private versus public?
Well, like the types of rockets.
Oh, yeah, I mean, with the kind of chemical rockets that we're using now, I feel like that is a pretty safe bet because it is a proven technology, even though it is slow. But I do think it's best to go with something that is tried and true, and we are comfortable and certain that it will make it there.
Tried and true method. Yeah, it's good to have a cautious approach, I think, for sure,
I think
especially
so
with
too.
some of these payloads, as Harry's asking about, how do they adjust? What do they have to do when they have different types of payloads? Like, so do all rockets sort of like have to have like a certain weight to them?
Oh, that's a good question. I think so. When they do payload adjustments, it's really adjusting the amount of propellant that you're putting in to the rocket. But they do have a cap, so you can't put an unlimited amount of stuff onto the rocket because it's going to get exponentially harder for the rocket to lift up because you need so much more fuel. So they do have a limit as to how many kilograms of stuff they can bring up on a spacecraft because, it is really expensive to even send 1 kilogram of stuff. I think right now the cost for NASA is somewhere between 10,000 to 20,000, and then for private companies like SpaceX, a little bit lower than that. But I don't really have a few $10,000 to spare for a couple kilograms to send to space, so they really have to make sure they're within range.
Now, if we're thinking about, now I know some of the plans for developing, say, like the lunar base, and a lot of the advantages to that would be you could have a rocket take off from the moon, and it wouldn't be as expensive as launching it from the Earth. Do you have any sort of idea looking into the future as to what those rockets might look like if they were just taking off from the moon?
Yeah, so they would be a lot smaller because you don't have to. The moon's gravity is a little bit less than here on Earth, so you have less to fight against, and you're going a shorter distance. You're going just towards the Lunar Gateway. So I'm really excited for the Lunar Gateway because I think that it's a really good first step to going to future, further, deeper space missions. And yeah, I'm excited to see what that's going to look like.
And a question also coming through is about solar sails. Now, is there any chance that we could potentially use solar sails for propulsion?
So solar sails work by using photons coming from the sun. So photons, as they hit a solar sail, they impart momentum. By conservation of momentum, you have momentum transferred to the solar sail and to the spacecraft, and it pushes it forward, and then the photons bounce off. So how much momentum transfer or impulse you get from these photons and how far or how fast you're able to push these solar sails is something I'm going to leave to the NASA researchers. But I do have high hopes for that because it is an interesting piece of technology.
Yeah, for sure. And I know that the Planetary Society, which I follow
Mhm.
quite diligently, they actually have a solar sail up in space right now, and you can actually follow it. It's more sort of like a proof of concept. It's not really doing a whole lot. Like the Planetary Society is a society that we could all join, and part of what they're trying to do is to encourage, companies to think about this technology. And it's amazing. Like this is their second one, and it's working. Solar sailing does work. It's certainly, I don't know if it's effective enough to maybe travel. It looks like it's pretty slow.
I was going to say, yeah, it would take a long time to get to even Mars.
Yeah, for sure. But it's cheap. It's free fuel, I suppose.
Yeah.
Another question coming in about launching from the moon. How can they power up? So can they harvest hydrogen using other fuels from the atmosphere or ground?
Ooh, so I imagine when they are launching rockets from the moon, they'll have to transport fuel to the moon. I'm not sure if there would be any sources of fuel on the moon as of now. I mean, we did have actually recently a really cool discovery with a lot of metal in the south pole of the moon. So I'm going to say that I'm not going to rule out the possibility. But yeah, so they will have to bring up the fuel. And with the idea of the Vastimer engine, the reason why that was so attractive as a potential idea is because you can get hydrogen from our solar system instead. So you don't have to bring that fuel with you, and you can refuel as you're flying and as you are coming back from your mission. And that's really cost effective.
Yeah, for sure. Another question coming in from Javid. How do you expect to get the materials required to build the rockets on the moon, even the base itself? If they plan to ferry it from the Earth, would that not defeat the whole purpose?
Ooh. Yeah, so they will have to transport materials from the Earth to the moon. I don't think that it necessarily defeats the purpose because you do have to transfer all those initial materials, make sure that you have everything set up at the beginning. But once they're solid and set up on the moon, then they can start doing things more autonomously. Like the Lunar Gateway is supposed to be fully autonomous, so we don't need to have crew on there continuously like we do on the International Space Station. So once they're all set up, good to go with the Canadarm3 and also robots like Dexter, they should be a-okay.
Of course, whenever I think about AIs and fully autonomous space stations on the moon, I think about the movie Moon, starring Sam Rockwell, and how there was all these AIs that were very lonely up there, doing a lot of the work. And probably in the beginning, it would be very lonely because like there would be just a lot of like tedious work setting these bases up, and there wouldn't be a lot of people around. If you haven't seen Moon, it's a fantastic movie. I really enjoyed it. Speaking of shows, though, Pride wants to know about Space Force. Did you watch Space Force, Rachel?
I did, and you know what? I watched it all in one sitting. It's a little embarrassing to admit on a live stream, but I did watch all 10 episodes in one
Okay.
sitting.
Let's, let's do a little fact check. I didn't watch. I think I watched up until like the last few episodes. So let's talk about Space Force for a minute and sort of like what are sort of like the realities and some of the myths, and maybe some of the like the true things from the show.
Yeah, so what I really loved about Space Force is that it was a nice kind of commentary on what's going on right now with public organizations like NASA and the US government, right? They're always kind of head to head trying to get funding for science and research. And so I really liked that kind of play where, you had a general who just wanted all these things to happen. And then you had these science advisors being like, well, here's why this is difficult and why we have to take other steps or other precautionary measures before we can get to the thing that you want to do. So it's really this kind of like having a science advisor and having politicians listen to what these science advisors are saying because this is their realm of expertise, and having that kind of tug of war between what they want versus what organizations like NASA want.
Yeah, no, that's a really good point. And of course the science advisor is played brilliantly by John Malkovich, and I imagine that would be like a really important role for scientists to play because they're at the place as a scientist where you can really institute a lot of change. But then, of course, they're dealing in a whole new world. Like this isn't the pure science world. This is now politics. This is a government agency. So for a scientist, they would have to almost play the game of politics and create relationships with the politicians to create trust. And like, you need to trust me because this is the safe way to go. But I know sometimes those decisions that you make, especially when it comes around space travel, like there's other factors at play that maybe don't go along with like just pure science. There's, because people want to stay in office, or like there's certain contracts that they want to fulfill. I always find that dichotomy really interesting, and it does make an interesting sort of like window. And I don't know how much they actually knew about sort of like those relationships. I always wonder, like, did they just make it up? Did they know somebody that used to be like a science advisor? I always wonder about that. But there's a lot of great comedy in the show, and I love the interplay of Steve Carell and John Malkovich. It seemed very realistic. Let's go back to a question about the space shuttle. Of course, you had a little neat little GIF. Oh, by the way, I loved my portrayal in your presentation today, Rachel. Thank you for the bow tie. It's been a while since I've worn a bow tie. Space shuttle could be considered the first reusable space plane. What are the prospects for more space plane concepts?
Ooh, so I'm not very well versed in this. And I haven't heard much about it because mostly in the news, it's a lot of the concept of reusability and sustainability for rockets and going into space, because we do have that problem of space debris. That's kind of an ongoing issue, a kind of underlying issue that we have, and that concept of reusability is super strong. So if they are coming up with more spaceplane concepts, I imagine that this would be the focus of that.
What about like space elevators? There was a lot of talk many years ago in thinking about. So when you think about the future of rockets, we're really talking about the future of getting into space,
Mhm.
right? So rockets has really been like the only way to do it because we don't have beaming technology. We got to just beam up there into space. But this idea of taking a space elevator up into space
Mhm.
was really intriguing. What are your thoughts on space elevators?
So it's an interesting concept because it does utilize the same principles that a rocket does. You know, in the elevator, you do have a counterweight, so you have something that is falling down, and then that thing falling down actually lifts up your elevator and theoretically would shoot you up into space. But I kind of categorize space elevators in the same realm as Dyson spheres, in that it's a really grand idea, and if it works, that would be fantastic. Going about the implementation process and actually turning it from science fiction to reality is, I think, a very difficult step.
Yeah. Yeah, I always like, I understood the concept, but just thinking about, you know, the ground, being like rooted in one spot and then having it to like also turn with the earth as
Yeah.
well. I think, and the materials, of course, and just building it. I think from what I read in the past, that was really where like the major problems would come in, would just be how expensive and difficult and dangerous
Yeah.
just building it in the first place would be.
It's definitely a logistical nightmare.
More questions coming in. Do you think that space shelters will be available to the general public in the future?
Yeah. The short answer is yes. I think that humanity often surprises me with how quickly and how advanced we have worked with our science tech. And, like with the Lunar Gateway and building a moon base, that's a great first step. And I think that that is going to be a great proof of concept if it hopefully works out well. And I don't know if I'll be alive for space shelters to be available at a cost efficient level for people like me and the general public, but I do have high hopes for humanity colonizing other moons and other planets.
Yeah, and I think like it certainly seems that perhaps little trips up in the upper atmosphere, which some citizens have been able to do. I think just that alone is something that I think would be very intriguing and I think very worthwhile. I think like more people would appreciate sort of the whole concept of space travel and just how difficult probably the payoff of how expensive it is, but then also getting there and having the visual awe of the Earth and being in space.
Like
I think it's
behind me.
important. Yeah, exactly. I think but here's the thing, Rachel. I think like seeing those pictures and when we watch movies, it seems not real, you
Hmm.
know? And
Hmm.
when we look up at the stars and in our nighttime sky and they're fading away and like the stars in space almost now seems like science fiction that it isn't real.
Yeah,
And I think that there is some value there for like just ordinary people, not scientists or politicians, to go up there and see that.
Chris Hadfield, a CSA astronaut, um, actually said that he wished that everyone on Earth could experience that overview effect and see the Earth from space because it really does give you kind of a different picture. Like if you're up in space, there's stars all around you. Underneath your feet, it drops below to blackness with stars. And being able to see our Earth from space as one global community, I think is very strong.
Cool. Yeah, no, absolutely. And Chris Hadfield has been a great advocate for it, and I think that's something that astronauts have been sort of like slowly switching into. It's as even as we've talked with our astronaut candidates, Jeremy Hansen, and coming up, we've got Joshua Kutrick, and there's this other part of their job, which is, just to inspire space. Like they are privileged enough to get to go. So like through them, it's like almost like through their eyes and through their words and through their emotions, it's important for us to experience that until we can get to the point where maybe we can send you up into space, right?
Yeah, I
Um,
would love that.
let's go back to Javid. So for the Lunar Gateway, do you think that the extra Delta 5 savings of launching from such a location would enable us to go even further than ever before?
Ooh, that's a good question. I don't specialize in astrodynamics, so in terms of the delta V savings, um, quantitatively, I'm not sure. But you know, it is like the trip to the moon, that few days is already a good saving point. You know, so being able to start from somewhere that's a little bit further and being able to save those few days is extremely valuable in term not only in terms of cost, but also like things like radiation exposure. When people are exposed to solar radiation, the more that we can shorten that time that they're exposed, the better.
Awesome. So we've only got a few more minutes, and I did want to chat with you, Rachel, because there's been some visitors that have been appearing in our nighttime sky. Now, of course, I haven't seen them yet, but I've seen lots of amazing photos coming from NASA, from the International Space Station. There was a comet that is passing by Earth. Could you tell us about this comet, and can we see it up there in the sky?
Yes, I would love to. So I'm just going to share my screen really quickly. But so Comet NEOWISE is the comet that is on all the news headlines right now. And the reason why it's exciting is because it is a visitor to our solar system. So it has a near parabolic orbit, which means that it'll come by, fly by us, and then go on its way outside of the solar system. So it's really only here for a short amount of time. So it really is this once in a lifetime opportunity to be able to see this comet. Now it's exciting because it's really bright. So it has a magnitude of around 1 or 2 based on the latest observations. And I know that doesn't sound like very much, but magnitude scales are logarithmic. And the lower the number going into negatives, the brighter it is. So to give you an idea, our sun is around -27 and our moon is around -13-ish. So having 1 or 2 in magnitude is fantastic. So I'm sharing with you the view of our nighttime sky. And you can see in the bottom corner, we have Comet NEOWISE. It's in this kind of purplish blue color, and it's in the constellation Auriga. So I'm going to teach you how to find it. So what you want to do is you want to look for Capella, which is the brightest star in the constellation Auriga. And it's easy to find because it's actually the 6th brightest star in our nighttime sky. And what you want to do is you want to draw a line from Capella down to Menkainen. And then you want to draw that line down and towards the left. And then when you draw that line, you'll end up at Comet NEOWISE. So if you wanted to go look in the next few days or so, the comet will actually be the highest in the dawn sky this Saturday, July 11th. So that would be the perfect time to go. You will have to be somewhat of a night owl because 3 or 4 a.m. is actually the best time to go look for it, and dawn hours right now. And you want to look towards the northeast. But if you wanted to go look for it, let's say later in the month, then you'll be wanting to look towards the northwestern skies, and you want to go just after sunset, so dusk. And you really want to go sooner rather than later because we did have this experience with Comet Atlas where it broke up before many people were able to see it. So I would highly recommend trying to get out and observing this comet. And what's really cool is that so it just completed its closest approach to the sun. That was on July 3rd. And now it's heading towards the closest approach to Earth. And that's on July 22nd. So it's a really cool comet to be able to see. If you have binoculars, you will be able to differentiate the 2 comet tails. We talked about that last week. But it should be able to see it with your naked eye as long as you're in some sort of dark sky location where you don't have a lot of light pollution. But if you do have light pollution, then I would highly recommend grabbing a pair of binoculars and heading out there.
Okay, yeah, no, this is exciting. I mean, like, of course, comets sort of like always come and go, and they're, as you said, Rachel, they can be very fickle because they're very hard to predict. As they come closer to the sun, are they going to break up, and it's going to make its pass around the sun? And, it might be visible in the evening time, but maybe it's to be cautious, to use the cautious astronomer Rachel approach. That's seems to be your motto. Get out there and see if you can catch it. 3 or 4 a.m. does seem pretty late, but maybe it's worth it. It's summertime. Maybe go to bed early, maybe set an alarm to see if you can catch it, especially if you're out there in a dark sky spot. Let's end us off with a nice, this is a really nice question coming in from Jamie, who's age 7. And Jamie wants to know, what does the Earth look like from space? Now, I think let's take this approach and let's think of it from like an alien point of view. And let's say, just like we are perhaps looking for life on other planets, if there was some alien astronomers that were able to come into our solar system, what would they see?
So that's a good question. So our Earth is often described as a blue marble, and that's because it's covered in oceans, covered in liquid water. And so it really depends on how close these aliens are coming to our planet. So if they were pretty close, you'd be able to see something like this I'm showing you right now with our planetarium software. But if they were looking from very far away, let's say in their own exosystem on their own exoplanet, they would probably only be able to see maybe the spectrum of our atmosphere and see what kind of chemical elements are in our atmosphere. And maybe by identifying what those elements are and seeing that they are the ingredients for life, then they would be able to see us and maybe come visit one day.
Yeah, and it's really intriguing. I think, like as a planetary, science enthusiast, looking at so many different pictures of worlds, not only in our solar system, but like the moons among the planets as well. There really is nothing like the Earth, is it? Like that, like those deep blues of the water and the clouds of the whites. Like it's really a striking world to look at.
It is somewhat terrifying to think about the fact that we are this one blue marble in the vast universe, but I try not to think about that too much.
Awesome. Well, Rachel, let's end it off there. Thank you, everyone out there in YouTube land and also on Telos Optic. Of course, every week we have lots of activities and blogs. If you go into the comment section description, sorry, not the comment section, the description of this YouTube channel, you can go onto our website and see all of the activities and blogs that we have. We've got an activity, of course, every week on our theme with Morgan from Let's Talk Science. And of course, if you enjoyed these weekly Q&As with Rachel, and if you have anything to contribute, please go to our donate page on our website as well. We would really appreciate it. Next week, as I flip the page, we get a little teaser talking about the Lunar Gateway. We are going to be talking about the moon. And of course, there's always lots to talk about there. So stay tuned for next week. See you next time.